Hello friends, so here we are with another question on electric charge, multiple electric charges, superposition principle. So the question is that we have an equilateral triangle ABC of side 10 meters, 3 sides. D is the midpoint of BC, okay, one of the sides BC, and we have charges plus 100 coulomb, minus 100 coulomb and plus 75 coulomb placed at points B, C and D respectively. What is the force experienced by a plus 1 coulomb charge which is placed at A? This is the information that we are given. Now our job is to translate this information into an accurate diagram. That is very important. That is the first step to solving any question, especially in physics. So let us draw the diagram. Okay, we have an equilateral triangle. Okay, this is one side. Let's say this looks okay. Okay, we'll manage it. Okay, this and this. Okay, we have B, C, A, three corners, three vertices. Then we have charges B, which is plus 100 coulomb, C, which is minus 100 coulomb, and let's say this is the midpoint. Okay, this is the midpoint D. Here we have plus 75 coulomb. Okay, it should be slightly towards the side. Okay, this is the midpoint. Okay, this is T. Okay, so again another important thing is the angles. It is 60 degree, sides are 10 meters. This is plus 1 coulomb at A. Okay, so now we have to determine the net force acting on this 1 coulomb charge which is placed at A. Okay, this is our task. Again, we'll find the interaction force between two charges because of all the charges that are present, B, C and D. Their interaction with A, it will lead to three forces acting on A, total of three forces acting on A. First force will be because of the interaction between charge placed at A, that is 1 coulomb, charge placed at B, plus 100 coulomb, both are positive, same sign. So it will be a repelling type force. It will be this. Let's say it is F A B vector directed away because it is a repulsion type force because the charges are same, they have same sign. Another force will be because of the interaction of charge A, charge D, 1 coulomb plus 75 coulomb. Again, both the signs are same, so this will also be a repulsion type force. It will be like this in the upward direction, vertically upward direction along the y-axis. If we say positive y-axis, it will be this F AD vector directed away because it is a repulsion type force. Another one will be because of the interaction of charge A plus 1 coulomb and charge C minus 100 coulomb. It is opposite sign, so it will be an attraction type force and it will be like this. This will be AC, let's say FAC vector. Okay, now the best way to solve this will be through resolving all the forces, their components in x and y direction. So we'll do that. Now first we have to determine the values of FAB, FAD and FAC. So first F A B, their magnitudes, 1 by 4 pi epsilon 0 QA QB RAB whole square. QA is 1, QB is 100, RAB is 10 square, and 1 by 4 pi epsilon 0, which is 9 into 10 to the power 9. So this is 100 will get cancelled, there will be 9 into 10 to the power 9. FAB. This is an attraction or attractive type force. Then is FAD. Okay, so for that FAD we have to determine this length AD. D is the midpoint, okay, D is the midpoint, so this one will be 5 meter. This is a right angle triangle, this will be 90 degree. So this one, applying Pythagoras theorem, it will be 10 square minus 5 square. This 10 square minus 5 square, applying Pythagoras theorem. 5 square plus this one will be 10, and this will be root over of 10 square minus 5 square, AD, the length of AD. AD will be equal to this much. So FAD will be equal to again 1 by 4 pi epsilon 0 QA QD by RAD whole square, that is equal to 9 into 10 to the power 9 into 1 into 75 by, this will be whole square of RAD square. This is RAD, the length of RAD, there will be root over of 10 square minus 5 square whole square. This is coming around, let us calculate. Okay, here it is also coming 9 into 10 to the power 9. Okay, 9 into 10 to the power 9. Please double check with these calculations. Okay, this is also an attractive type force. Sorry, this is again I made a mistake here. This is repulsion, okay, repulsion type forces, these two, because they are between same signs. By mistake I wrote repulsion attraction there. FAB is also a repulsion type force because both the signs are same. This is repulsion, this is also repulsion. Okay, the force is repulsive in nature. Okay, my mistake, please. FAB between charges placed at A and B, that is repulsion, okay, because both the charges, they have same sign, likes, okay, like charges, same kind of sign, nature. And FAD also plus 1 coulomb plus 75 coulomb, both are plus positive sign, so that will be also repulsive in nature, okay. FAB, FAD, they are repulsive in nature. Then is force FAC. Again it will be 1 by 4 pi epsilon 0, that will be equal to QA QC by RAC whole square, 9 into 10 to the power 9. QA is 1, this is minus 100, but put 100 here, we are only interested in the magnitude, okay. That is equal to by RAC, which is 10 meter whole square. 100 will get cancelled, this will be 9 into 10 to the power 9. This will be attractive in nature, attractive type force. Both these two, FAB and FAD, are repulsive in nature, they are directed away from the charge, and this is towards, okay, in between these two interactions, okay. Now we have got FAD, FAB and FAC. Now we have to resolve them into their horizontal and vertical components to solve it. So for that, what we'll do, we draw separately. We have these two axes, let's say, X and Y axis. we have charge A placed here. We have this as this is it will be slightly like this, okay. This is FAB vector, this is FAD vector, and another one is FAC vector, this way. FAC vector. Now the angle between FAB and FAC, that will be very important, this angle. So for that, what we'll do, we'll draw a parallel line to BC, parallel line to BC. This angle will be 60 degree, alternate angles. This angle will be 60 degree, corresponding angles. This one is 60, this one will be 60, this one will be 60, this one is 60. So total we have, the angle between them is 120 degree, this is 60 degree, and this is also 60 degree. So now we have to resolve them into horizontal and vertical components along x and y axis. So here we have FAB having two components, okay. FAB, it has two components, one along the x axis, which will be FAB cos 60 degree, and one along the y axis, which will be FAB sin 60 degree. So we'll write the total x and y components. So here the total component along the x axis, that is equal to FAB cos 60 degree, okay, the horizontal component of FAB. Similarly, FAC, it will also have a component FAC cos 60 degree along the x axis, along the x axis. So total x component is FAB cos 60 degree plus FAC cos 60 degree. So it will be 9 into 10 to the power 9 into 1 by 2 plus this one also be 9 into 10 to the power 9 into 1 by 2. Total it is 9 into 10 to the power 9 Newton, that is Fx. So this is Fx, horizontal component. Then for the vertical component along y axis, Fy will be, we have a vertically upward component FAD along the positive x axis, so that will be FAD plus the vertical component of FAB, which will be in the vertically upward direction. FAB, this one, it is in the upward direction, that will be FAB sin 60 degree. And we have another vertical component of FAC, which is along this direction, the negative y axis, that will be minus FAC sin 60 degree. Okay, so that will be FAD plus FAB and FAC, they are all equal. See here, FAB and FAC, they are all equal to 9 into 10 to the power 9. All are equal to 9 into 10 to the power 9. Okay, Newton, magnitude wise. So these two will get cancelled because FAB is equal to FAC is equal to FAD, that is equal to 9 into 10 to the power 9 Newton. Okay, So this will only be equal to FAD, which is equal to 9 into 10 to the power 9 Newton. So Fy is also equal to 9 into 10 to the power 9 Newton. Fx is also equal to 9 into 10 to the power 9 Newton. So again there is no confusion. See, we have resolved this into x and y components. Okay, FAB has a horizontal component along x axis, which is FAB cos 60 degree. FAC also has a horizontal component both along the positive x axis, that is FAC cos 60 degree. Both are added, we got 9 into 10 to the power 9 Newton. Similarly, we have to resolve the components along the y axis. FAD is there along the vertically upward direction, positive y axis, FAD. Then FAB, which is in this quadrant, the first quadrant, it has a vertical component along the positive y axis, that is equal to FAB sin 60 degree. FAC, which is in the fourth quadrant, it will have a vertical component in the negative y axis, that is minus FAC sin 60 degree. If you see here, FAB, FAD, FAC both have magnitude 9 into 10 to the power 9 Newton, equal. So FAB and FAC, they are equal, so they will get cancelled because their negative sign, they are getting subtracted. So we only have FAD. FAD is equal to 9 into 10 to the power 9 Newton, which is equal to the y component. So now we have got the x and y component. So the total resultant force acting on A, will be Fx square plus Fy square, which is equal to root over of 9 into 10 to the power 9 square plus root over of 9 into 10 to the power 9 whole square, which is equal to 9 root 2 into 10 to the power 9 Newton. That is the resultant force acting on A. Okay, so this is the solution. So it was a bit lengthy, but I had to make you understand about this is a very important concept, resolving of the components of vectors in the x and y directions. It makes the solution simple, analysis simple. So first we applied Coulomb's law, we got the magnitude as well as the direction of these force vectors, then we resolved the different components of the vectors along the x and y directions, then we summed them together and we got the net result. Okay.